Well, hello everybody. I'm back with bonus quiz for 2.2. It's a two-parter, and I thought I'd work the second part first because it makes sense in terms of explanations. Here they want us to determine whether the correspondence is a function. And so we have animals here instead of numbers, but the idea is the same. And that's nice because functions are used in science. And so it's not just about the math. It's about explaining the real world in terms of science. This idea of functions. That's a huge leap, and it happens under the umbrella of ordered pairs. I'm going to show you that here in a second. Now, they want to know if this is a function, this correspondence is a function, and to answer this, you have to have the definition of function in your mind. Now, this is what works for me. For every x, there is only one y. I couldn't make it any simpler for myself. For every x, there is only one y. You notice this doesn't say anything about for every y, there's only one x. It's just talking in terms of one direction. For every x or input, there is only one y or output. Let me flesh that out a little bit more because that's a huge moment in the course. There's a lot going on here. There's a lot of different words for the same thing. And we need to look at that. Now, everybody understands an ordered pair x comma y, and it's nice the way they've done that. X precedes alphabetically y. So this is an alphabetical order. They talk about functions as being input and output, and that's the leap out of math and into science. And I comes before O in the alphabet. In science, we talk about causes and effects, and notice C precedes E. And if I go back to math, and the bigger idea here, they call the allowable x's the domain, and the resultant y's the range. And this is an alphabetical order. In fact, everything is an alphabetical order. So that's really nice. And it allows us to imprint this in our minds. Now, for every input or every x, there's only one y or output. And that's the case here. Cat doesn't go to a mouse and a cat. It just goes to a mouse. And a boa just goes to a mouse, and so forth. There is no situation here where an input goes to more than one output. So the answer here is going to be yes, this correspondence is a function. And just to make sure you've got that, let me show you quickly here a more realistic view of the predator-prey situation. Everybody knows that boas are hungry creatures. They will eat anything that they can wrap up according to their size. And so it makes sense that a boa would, in fact, regard a cat as a prey. And at this point in time, boa is mapping to both mouse and cat, so an input is going to two outputs, and this would not be a function. So that's the answer to this first problem. And let me click on yes. And now let's get to this second problem, or actually it's the first problem. And they're asking us now, find the domain of the function. Now this is going to haunt the course. You're going to see this time and time again. And the idea here is domain is the x's, the legitimate x's, and y's are the resultant ranges. And so they're asking us for the legitimate x's here. And you're supposed to know, this is the major commandment, the first commandment of mathematics and of our course, that thou shalt not divide by zero. And so everything is allowed here. When you're dealing just with a math problem like this is pure math. It's not a word problem. There's no science involved or anything like that. It's assumed that you want the domain to be everything, except for what turns out to be illegitimate. In this case, we don't want to divide by zero. And so we have to find the situations here where the denominator will take on zero. And so we rip this out, this denominator out, and we create a subproblem. We say x plus 12 is equal to 0. We want to know the situation where x will cause a 0 in the denominator. And so x is equal to negative 12. So when x is negative 12, the denominator will be 0. We'll be dividing by 0, and that'll be a no-no. We have to restrict that situation. And so the conclusion here is we can't let x ever be negative 12. You look at the alternatives here. Set-Builder notation is read x such that x is a real number and x is not equal to negative 12, as opposed to b, where x such that x is a real number. Remember, the default condition when you just have math is r, every possible real number. And then you're going to look at what situations where it's prohibited, in this case dividing by 0. We said it is going to be this, x can't be negative 12, and sure enough we got both questions correct. I hope that helps.